Good morning, class. Today we discuss dipole moment. Students, dipole moment is represented by letter mu. Dipole moment is defined as the product of magnitude of charge and the distance between the center of positive and negative charges. It is represented by letter mu and its SI unit is coulomb meter or represented by Dipole. It should be noted 1 dBi is equals to 3.33 into 10 raised to power minus 30 coulombs meter. I repeat it again. Dipole moment is defined as the product of charge and the distance between the center of positive and negative charges. That is mu is equal to charge into distance between the center of positive and negative. Its SI unit is coulomb meter or represented by capital D called dBi. It should be noted 1 dBi is equals to 3.33 into 10 raised to power minus 30 coulombs meter. Dipole moment is represented by tailed arrow whose direction is from electropositive to electronegative element. For example, in case of HCl, chlorine is more electronegative, so the direction of dipole moment is from hydrogen to chlorine. Since chlorine is more electronegative, so the direction of dipole moment is always from electropositive to electronegative. Now let us discuss a question why CO2 molecule has zero dipole moment. I repeat again, why CO2 molecule has zero dipole moment. Since the structure of CO2 is represented like this manner, out of carbon and oxygen is more electronegative element, so direction of dipole moment is toward oxygen atom. Similarly, in such situation also, since two dipole moment direction are opposite oriented and equal in magnitude, cancel each out, thus its CO2 molecule show zero dipole moment. I repeat it again, CO2 molecule show zero dipole moment because the direction of two opposite oriented dipole moment are equal in magnitude and opposite in direction, thus the total magnitude comes out to be 0. Now let us consider the case of ammonia and NF3. We have to find which out of NH3 and NF3 have high dipole moment or large magnitude of dipole moment. First we draw the structure of NH3, that is ammonia, and NF3, nitrogen trifluoride. In case 1, out of hydrogen and nitrogen is more electronegative, pull electron toward itself like this manner, Also dipole moment due to lone pair in upward direction. The magnitude of the resultant of these three dipole moment act on upward direction. Also dipole moment due to lone pair is in upward direction. So this molecule show net dipole moment. Ammonia molecule show net dipole moment, but in case of NF3, out of nitrogen and fluorine is more electronegative, so the direction of dipole moment is towards fluorine, but a dipole moment due to lone pair act on upward direction. The resultant of these three dipole act on downward direction, and the dipole due to lone pair on upward direction. Both dipole moment cancel each out, but not equal in magnitude, therefore it show very less dipole moment. So out of NH3 and NF3, which would have highest magnitude of dipole moment? Obviously NH3. Now let us discuss Fajan's rules. According to Fajan's rule, smaller the size of cation, greater is the polarizing power. I repeat again, smaller the size of cation, larger will be the polarizing power. Similarly, the larger the size of anion, more will be its polarizing power. That is why lithium iodide is more polarizing power than lithium bromide, than that of lithium chloride, and then lithium fluoride. Since the size of iodine is larger, therefore it has more polarizing power. Since number third, larger the charge on cation, greater will be its polarizing power. That is why FeCl3 has more polarizing power than FeCl2. Also, number 4 point, if two cation of same charge and same size, then the cation with one pseudo noble gas configuration has more polarizing power. For example, CuCl. For example, CuCl has more polarizing power than that of NaCl because copper has pseudo nearest noble gas configuration as compared to sodium. Now, let us discuss hybridization. Student, hybridization is defined as the intermixing of atomic orbital of slightly different energies so that the redistribution of energy take place, result the formation of atomic orbital having identical energy and shape. I repeat it again. Hybridization is the process of intermixing of atomic orbital of slightly different energies so that the redistribution of energy take place, result the formation of atomic orbital having identical geometry and shape. Student, hybridization are of following types. Now let us discuss type of hybridization. In sp hybridization, as the name indicate, one s and one p orbital involved. The geometry of this type of hybridization is linear, and the example of this type is BCl2 and C2H2. All the carbon-carbon triple bond compounds show sp hybridization, sp2 hybridization, in which one s and 2p orbitals are involved. Its shape will be trigonal planar. The example of this type of hybridization is BF3. All the carbon-carbon double bond compounds show sp2 hybridization. Now let us come on sp3 hybridization, in which 1s and 3p orbitals are involved. Its shape will be tetrahedral. And the example is SnCl4 and CH4. All the carbon compound containing carbon-carbon single bond show sp3 hybridization. Now let us come on dsp2 hybridization, in which 1d, here d orbital generally dh2y2, and 1s plus 2p orbitals are involved. The shape of this type of molecule is square planar. And the best example of it, PtCl4, signal negative charge. The example of this one is PtCl4, 2 negative charge. Now let us come on sp3d hybridization, in which 1s, 3p and 1d orbital generally involved in hybridization. The shape will be trigonal bipyramidal. Trigonal bipyramidal shape will be there, and the best example is PCl5. Now let us come on sp3d2 hybridization, in which 1s, 3p and 2d orbitals are involved. The 2d orbital generally involved, dh2y2 and dz2 orbitals are there, and the shape will be octahedral, and the example of it is SF6. The last type of hybridization is sp3d3 hybridization, in which 1s, 3p and 3d orbitals are involved. In 3d orbital, dxy, dyz, dzx orbitals are there, and the shape will be pentagonal bipyramidal. Pentagonal bipyramidal shape will be there, and the example of it is IF7. So from this chart we will notice the type of hybridization are of 7 type: sp, sp2, sp3, dsp2, sp3d, sp3d2 and sp3d3, in which the total number of orbitals 2, 3, 4, 5, 6, 7 are involved. Their respective shapes are mentioned and the examples are given below. Now student, there is a formula for calculating hybridization. Student, there is a formula for calculating hybridization also. It is hybridization can be calculated with the help of a formula. According to this formula, H is equals to S plus 1 by 2 E minus V plus minus C. According to this formula, H indicate hybridization, H indicate hybridization, S indicate number of surrounding atoms, S indicate number of surrounding atoms, E indicate valence electron of central atom, V is the valency of surrounding atom, C may be defined as the charge. It should be noted if taken to be positive for anion and negative for cation. Now let us consider an example. Suppose we have to calculate hybridization state of carbon in carbonate ion. So according to the formula, H is equals to X plus 1 by 2 E minus V plus minus C. Number of surrounding atoms are 3. For oxygen plus 1 by 2. Total number of valence electron present in carbon are 4. Valency of oxygen is 2, but 3 atoms are there, so multiply by 3. 2 negative charge is there, that's why we adding here 2. The value of H comes out to be 3 plus 1 by 2, 6 minus 6. That is the value of 3. H comes out to be 3. For 3, sp2 hybridization will be there. Now let us take one more example. NH4 single positive. Apply the formula in which we have to calculate hybridization state of nitrogen. Total number of surrounding atoms are 4 plus 1 by 2. Total number of valence electron in nitrogen are 5. Hydrogen has valency 1, multiply by 4 because 4 atoms are there. Since 1 positive charge is there, subtract 1. So the value of H on solving comes out to be 4. That is sp3 hybridization will be there. Let us take one example which doesn't bear any charge. That is, let us consider the example of PCl5 in which we have to calculate hybridization state of phosphorus. Here value of H may be calculated. Total number of surrounding atom plus 1 by 2, 5 minus 5 into 1. Since chlorine has valency 1, no charges there, so plus 0. So the value of H comes out to be 5. Does it show sp3d hybridization? So with the help of this formula, we can calculate the hybridization state of underlying element in the given species. I repeat it again. According to hybridization formula, H is equals to S plus 1 by 2 E minus V plus minus C. H indicate hybridization, C is the number of surrounding atom, E is the valence electron of central atom, V is the valency of surrounding atom, and C is the charge. Positive for anion, negative for cation. Now student, let us draw the formation of sp hybridized orbital. Student, sp, as we described earlier, sp hybridized orbital is formed by the combination of one s and one p orbitals. Now let us summarize sp hybridization. sp hybridization in which one s and one p orbital involved. Here the z axis, y axis, px. When one s and one p orbital involved, sp hybridized orbital form are of like this type. The bond angle is 180 degree. The shape will be linear. sp hybridized orbital shape will be linear and structure represent like this manner. Now let us consider number 2. sp2 hybridization. As in sp2 hybridization, one s and two p orbitals are involved. It is generally px and py. When one s and two p orbitals are involved, we will obtain sp2 hybridization. The shape of hybridized orbital like this manner. The bond angle between them is 120 degree and the shape will be trigonal planar. So the shape of sp hybridization is linear, sp2 hybridization is trigonal planar. Now let us consider the third one, sp3 hybridization. In sp3 hybridization, as the name indicate, 1s and 3p orbitals are involved. It is px, py and pz will be there. They result the formation of this type of orbital. The bond angle is 109 degree and 28 minutes, and the shape will be tetrahedral. The shape of sp hybridized orbital is linear, sp2 hybridization is trigonal planar, and sp3 hybridization is tetrahedral. It should be noted, more the s character, more will be the acidic state. In sp hybridization 50% s, 50% p character. In sp2 hybridization 33% s and 67% p character. In sp3 hybridization 25% s and 75% p character. More the s character, more will be the acidic strength. Now student, let us discuss the hybridization involving d orbital. Now let us discuss hybridization involving d orbital. Hybridization involving d orbital PCl5 is there. Phosphorus has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p3 and then 3d0. In phosphorus in ground state, GS ground state, 3s, 3p, 2, 3, 4, 5. It's for 3s, it's for 3p, it's for 3d. In s orbital 2 electrons are there, p orbital 3 electrons are there, d orbital contain no electron. But in excited state, es dot बोले तो excited state, 1 electron from 3s orbital jumps to 3d orbitals. 3d orbital. Now there are 5 unpaired electrons which may get paired by sharing 1 electron from chlorine in formation of PCl5. In PCl5, these 5 unpaired electrons get paired by sharing 1 electron from chlorine. Thus, total number of orbitals involved during this process are 5. That is 1s3p and 1d, that is sp3d hybridization will be there, and sp3 hybridization shape will be trigonal bipyramidal, and the structure represented like this manner also. PCl5 has trigonal bipyramidal structure. These are the axial bond and these are the equatorial bond. The vertical bond are the axial bond and this one will be the equatorial bond. It should be noted the length of axial bond is greater than equatorial bond due to more electron repulsion in them. I repeat again, length of axial bond is greater than equatorial bond due to greater electron repulsion in them. Now let us draw the formation of C2H4 and C2H2 molecule. Students, C2H4. In C2H4, if we draw the roughly structure, the carbon atom is double bonded. That is, double bonded carbon atom always show sp2 hybridization. It is for first carbon, it is for second carbon. Now there is a partial orbitals which contain 1 electron. Hydrogen will be there. Bonding take place. Overlapping take place, sigma bond form the structure of C2H4 molecule like drawn this manner. Similarly, we can draw the structure of C2H2 molecule. In C2H2 molecule, carbon atom is triple bonded and triple bonded carbon atoms show sp hybridization. These for hydrogen, partially orbitals are there, like this manner. Join first by first, second by second. The bond form like this manner. So here it is. Here we draw the structure of C2H4 and C2H2 molecule on the basis of hybridized orbital. Thank you very much.